friends, students, and enthusiasts. So welcome back to my channel. So I have come up with a new topic that is on PWM made simple. That is why pulse width modulation is important in electronics. PWM stands for pulse width modulation. Okay, so we will study or we'll have a little idea about it and why it is important in electronics, especially for the projects, that is electronic projects. Okay, right. So understanding pulse width modulation and its application. So have you ever wondered now how we control an LED? Like there is a LED bulb, the brightness of LED or a motor, there is a motor, the speed of that motor, if it is to be controlled, or let it be a servo motor, or the positioning of the servo motor, tilting of the servo motor, even power in modern electronic devices like SNPS and other devices, you have power related things. The answer is PWM, right? So LEDs, motors, power supplies, everywhere we use PWM. That is why it is important to understand pulse width modulation. So there is a small graph type of this thing, pulse are there. That is on the top, it is written on time. On the bottom side is written off time. So this is a duty cycle percentage wise. We will take this part, that is on time part, as 50, and period, we will take this frequency as period and amplitude. So basically it is on and off pulse. Okay, right. So we'll come to the definition part actually. So PWM pulse width modulation is a technique used to control power delivered to an electronic device by rapidly switching the signal on and off. So high speed switching that takes place in the SNPS switching, like transistor will work on and off. That is, it will switch on and off in a very high frequency. So there also we use the same type of pulse, right? So instead of changing voltage, that is, we are changing the voltage directly, PWM changes the amount of time the signal remains on, right? So you can decide what time till what time the signal remains on. That is the good example for you to understand what is PWM. All right. Okay. Now we'll come to the next slide. So understanding duty cycle. This is very important. What is duty cycle? As on the right hand side, you can see that is 25 duty cycle. This is 50. It's almost double the size of this in 75 duty cycle. Okay. So these are the this is modulated. That is on time. This is 75. This is 50 duty cycle, and this is 25. These are the on and off cycles, we say. Okay. So how it is calculated? So duty cycle is equal to on time by total time multiplied by 100%. Okay. That is multiplied by 100. So example, just take an example. 0% off, like 0% it is off. We call it a 0. If it is 0, it is off. 25%, as you can see on the screen, it is low power. We call it as a low power because the time this it will be switching on is less, right? This is on time on the top, it will be less. If it is 50, medium power, we call it as because the time has increased. And 100 means if it is continuously, it will be on, like continuously it will be on. So we call suppose 5 volt is there. I will just give you an example. 5 volt is there. So suppose 5 volt, if you always keep it on, we call it as a full power. We call it as a full power. Whereas 5 volt, when you put it to half, let's say 50%, half, then we are half the time on and rest of the time it will be off. We call it as a half power. If it is 25, then low power, or less than 25, it will be low power. So likewise, we categorize it in 3 different things. So let's have an explanation. The higher the duty cycle, the more power, which is the load. Okay, more. So 100% I told you every time on. So example is LED becomes brighter, motor rotate faster. That is, the duty cycle is high at that time, brighter. So that's why we use it here. Okay. So let's go to the next slide. Now this is the waveform. We are discussing about the waveform. What is the waveform? How it will be there? So PWM keeps voltage constant but changes the pulse width. Voltage will be constant as we have already discussed, but the pulse width and changes the pulse width, the width of the pulse. That is the square box is what you see here. So provide efficient power control without wasting energy as heat. Okay, the energy as heat. So PWM is like turning a light switch on and off. Very quickly, our eyes see the average brightness rather than the rapid switching. Because our eyes, if the frequency matches, then only we can see that brightness coming on. If the frequency crosses our limit, you cannot see it by the eyes. So this graph, that is A, B, C, D, different type of pulses, you can just see different type of PWM pulses we can see here. Okay. So why PWM is important? Why? Because first of all, what is the advantage? It is energy efficient, right? That is energy efficient, less power, it consumes less power. Easy control, that is simple adjustment of brightness and speed. We can do it here. So we call it as easy control. Digital friendly, microcontroller generate PWM easily. That is all the microcontroller embedded system board will have a PWM dedicated PWM pins to it. Okay, not all of them will work, but few of them will be there. Of course, accurate control, that is precise power regulation will be there. Cost effective, right? Expense data, you're not very this thing expensive circuit, no expensive circuit is needed in this. Okay, so you can see on the breadboard on your right hand side, I have used Arduino board. Some pulses have been given, that is 6 PWM pulses will pins will be there on this. All right, so application of PWM, where PWM is used, where it is used. LED brightening control, that is the project what we do or what we learn in the beginning. Mobile screen TV, LED lamps. So flickering on your screen, that is what you watch, the HD or LCD or LED TVs, that flickering is controlled. It is so fast that it doesn't come to your eyes. So all displays will use PWM pulses there. So that's why it's very, very important. So motor speed control, wherever you want to control the speed of a motor, like you can see here, I can control the DC motor. So speed control of DC motors, like electric vehicles nowadays, you accelerate, the speed will go high. When you reduce it, the speed will come down. So PWM pulses are used there also. Robotic drones, electric vehicles, I said. Servo motor control, there also we use it. Robotic arm and automation, like movement of arms, slow, fast. This is also controlled by PWM pulses. Audio amplifier also uses a PWM, the latest audio, that is called, we call it as a class D amplifiers, right? There also we use the PWM pulse. Power supplies, as I told you, power supply also we use. SMPS, battery chargers, solar system, that is MPPT, solar charging control. There also we use the PWM pulses. Why students should learn PWM? That is very important question. So PWM is one of the most important practical skill in electronics and embedded system. Learning PWM helps students understand Arduino programming, Raspberry Pi Pico programming, ESP8266 projects, ESP32 project, robotic automation system, IoT application. So almost it has covered all the fields, okay? And electric vehicle electronics also. So what are the career benefits? PWM knowledge is useful in embedded system, as we have already seen. We can do the projects in this industrial automation, robotics, EV technology, and IoT development. So why we should learn? These are the typical few of the things I have shown you. You should have idea about it. Okay. So we'll do a small project. I will just, after this slide, small project, I will show you. That is a simple PWM demonstration project. As the project is very small, you can see it's written in C. The component is 220 ohm resistor, breadboard, and it is connected to pin number 9. The LED will come bright, and the LED gradually becomes brighter and dimmer by changing PWM. The same time I have used with this, I will show you the motor also. Like if the dimming takes place and brightness changes, at that time my motor speed will also increase and decrease. Using the same codes, I will be showing it to you. Okay, so conclusion, PWM controls power efficiency, used in almost every modern electronic devices, essential skill for electronic students, foundation for robotics, IoT, and EV projects. Easy to learn using Arduino, ESP32, Raspberry Pi, Pico. These are the 3 important boards what we use nowadays. Okay, so final message is, if you want to become an electronic engineer, that is IoT developer, robotic enthusiast, or EV designer, PWM is the one of the first practical concept you should all try and master. So let's go to our lab and I will show you the demo. If you like this, please share with your friends. If this knowledge, if it is important for you, please do comment on me and please subscribe to my channel. So I will just tell you, this is my Arduino board I am using. I have connected pin number 9, as you can see, and I've given ground and supply. So on this board, as you can see, LED I have connected. Now how the LED is working, right? How the LED is working, you can just have an idea about this thing. It is going bright and it is going, you can see here how it is going bright. At the same time, I will show you the motor. According to brightness, the motor is also behaving the same way. Okay? So it is also behaving the same way. Okay, so you can just have a look. I'll just try to show it to you. Right. So just now it has stopped. You can see when the brightness come up, the codes are same. I have not changed the codes, but just wanted to show you. This is PWM pulse. So the codes are very simple. I have shared the code. The same codes can be used, and we can connect it with these things also. Okay. So I will remove it and I will show you how it is working again. How the PWM is working. You can see. See, the brightness goes up and comes down again. Right. So this happens only with the pulse width modulation. Okay. I hope you will like this. You like this video and this topic. If you liked it, please share with your friends and subscribe to my channel if you want more videos. Thank you very much.